Hello everybody. In this video, we're going to be finding the slope of a specific graph at a specific point. So here, we want to find the slope of the graph f of x is equal to x squared plus 1 at the point 5, 26. So this 5, 26 is a point on the graph, and we want to find the slope of the tangent line of the graph at that point, okay? So remember, the tangent line is, so this graph, since it's a x squared, it looks like a parabola. It looks something like this. And the tangent line is at any point on the graph is the exact slope of that point. So we're going to find the exact point of that at x equals 5, okay? Let it be noted that there are many ways to solve this problem, and we're going to be using the specific different quotient method to show how it works. It may not be the fastest way, but it is a way to solve it. So let's use it. So the quotient formula states that limit of change of x approaching 0 of f of x plus change of x minus f of x over the change of x is equal to the slope at a point, okay? And m is the slope. So let's f of x, we have our f of x equation here. So now what we got to do is plug in x plus change of x into the equation here, and then just simply x. And then we'll see what we get from there. We're plugging in these into our f of x. So let's write this. So we have limit of change of x approaching 0 of f of x plus change of x. So which means we plug the x plus change of x into our x in the equation. So that'll give us x plus change of x squared plus 1. Note how this is what we plugged in here. So that's this part. And now we do minus f of x, which is just the equation here. I'm going to write it parentheses, so we know we have to distribute the negative, remember that. And then all over change of x. So now let us simplify. So let's multiply everything out and distribute the negative. So how do we multiply? How do we do x plus change of x squared? Well, I'm going to be using the box method for this. There's various methods you could use, but I'm using the box method. So to use the box method, you draw a box first. Let me draw a nicer box. You draw a box, and depending how many terms there are, there's 2 terms here for both. Since I'm going to square in it, I'm have 2 boxes on each side. So x plus change of x on one side, each term. And on the other side, since it's square, it's going to be the exact same terms. X plus change of x. And now within each quadrant in the box, we just multiply the 2 corresponding numbers. So in this box we have x times x, which is x squared. In this box we have x times change of x, which is x change of x, simply that. We can't simplify it further. This one is also x times change of x, and this is change of x times change of x, so it'll be delta x delta or change of x squared. Okay, so now we have this, we multiply this out, so now let's write it out. So with first thing we have an x squared plus x delta x, but notice how we have 2x delta x's here, which means we had their like terms, meaning we're allowed to add them together. So that will give us 2x delta x plus delta x squared Okay, so this is with this squared. So now we have this plus 1. And now let's distribute the negative here. So minus x squared minus 1 all over delta x. So now whenever doing these problems, if you're doing it right, you should be able to cancel out a lot of things, okay? Not a lot of things, but you're supposed to cancel out some things. So notice here we have a positive 1 and a negative 1. So those two can cancel out with each other. Here we have an x squared and a negative x squared. So that can cancel out with each other, leaving us with 2x delta x plus delta x squared over delta x. So what do we do now? Well, let's try to get the delta x out of the denominator, because if we plug in the limit of delta x equals 0 right now, we'll get a denominator of 0, which we're not allowed to do because we're never allowed to divide by 0, okay? So the only way we could get delta x out of the denominator is to cancel it out. And in order to cancel it out, let's try to factor it from the top. So let's see if that's possible, okay? So can we factor out delta x from these two terms? Yes, we can. Notice there's a delta x here, and this is delta x squared. So I'm going to go ahead and factor delta x out and take out delta x here. We have a 2x plus, so delta x squared is basically delta x plus delta x, or sorry, not plus, times delta x. So if we factor out one delta x, we're just left with delta x by itself. So we have 2x plus delta x over delta x. Alright, and now notice how we have delta x term on the top and on the bottom. So we are able to factor it out, or cancel it out, sorry, not factor out, cancel it out from top and bottom. Just like that, meaning we have our new equation as limit of delta x approaching 0 is equal to 2x plus delta x. Alright, so now we have our new simplified equation, and now let's plug in delta x equals 0 since this is our limit. So you might notice plugging delta x for 0 will just mean this is 0, which means the slope of the tangent line of our equation is equal to 2x. Okay? But this is not the answer, because notice how we need to find the slope of the specific point at 5,26. So what do we do there? Well, we plug in our x value, which is 5. X value here. Okay, so we plug that into the equation, and that'll give us our slope as the answer at our point. So that's slope is equal to 2 times 5, which means our slope is equal to 10. Okay, so that's our final answer. The slope of the graph of x squared plus 1 at the point 5,26 is 10. Thank you for watching this video. I hope you enjoyed it, and see you next time. Bye.